Hello everyone, welcome to Algebra 2 homework 1.2 types of real numbers. We're going to fly right through this one, just like with the last homework. I'm not going to talk too much about the specifics here, but really just walk you through my thought process when I'm solving these types of problems. I'll talk a little bit about that now. So when I'm trying to figure out types of real numbers, I like to go as specific as possible. So I'll try and figure out, is it natural? If it is, then I know that we can automatically just check these boxes off: whole number, integer, rational, and real. If it's not a natural number, but it is a whole number, then we can do a similar process. We can check integer, rational, and real. So that's kind of my thought process for these types of questions. We go as specific as possible, and if the number doesn't fit in that category, we'll move on over to the next one. So starting off here, right at number 1, we're looking at a natural number. It's greater than or equal to 1, and it's a whole number. It's not defined or expressed using a fraction. It has no decimal places. So we're going to write natural. It's a whole number. It is an integer. I'm just going to go int for that. Rational. And above all, it is real. Now, what about the square root of 7 here? We know it's not a natural number, because it is expressed, well, it can't be expressed with a fraction of some kind. It's not a whole number, it's not an integer either, but is it rational? Rational numbers are, remember, numbers that have can be expressed as a fraction like 1/2 or 3/4 or even 1/3, even though that turns into 0.33 repeating. The square root of 7 does not do that. It is an irrational number. So that is irrational. And above all, it's real. And what about pi? Now, this is a pretty common example for an irrational number. It is one of those numbers that continues on for infinity. That's 3.1415. And like I mentioned in the notes, billions of notes, billions of decimals after that. So that is also going to be an irrational number and a real number. And what about 0? So it's not a natural number because it's not greater than or equal to 1. It is a whole number, though. Whole numbers are any number that can be expressed without a fraction, and it is greater than or equal to 0. So we're going to write whole number. It's an integer. It is a rational number, and it is a real number. Negative square root of 9. So that negative's out front, which means that this is not an imaginary number. If it were negative 9, but the square root of it, that would be imaginary. But that's not what we're dealing with here. We're looking just at the negative of the square root of 9. Now, when you see square root, it's easy to jump straight to the conclusion that it's going to be an irrational number. But this is not the case here, because the square root of 9 is just 3. So what we're looking at here is really just negative 3. Now, it's not a natural number. It's not a whole number, but it is an integer, which means that it will also be a rational number and a real number. So we'll write those in. We've got integer. We've got rational. And we've got real. Same type of deal here for number 6. This is a negative number, but it's not expressed using a fraction. It's not a decimal, which means that it is an integer. It is rational. And it is real. Most of the numbers that we'll be dealing with are going to fall into those categories. All right, and moving on to just checking the appropriate columns. Let's see. So if it's a whole number and it's greater than 0, that means it's going to be natural, whole, integer, rational, and real. Square root of 2. We can jump straight to irrational. And of course, it is real as well. Now 3/4 here. 3/4 is just expressed using a fraction. That would simplify down to 0.75, which would tell me it is rational and it's real. It's not an integer because it is expressed using that fraction, that bar right there. Let's see. -13. It's not natural because it's less than 1. It's not whole because it is less than 0, but it is an integer. It's not expressed using a fraction, which again makes it rational and real as well. Negative square root of 9, we already did that right here. It's just -3. And we can just copy our answer down. So it is an integer, it is rational, it is real. 0, the only whole number that is not a natural number, which makes it whole, integer, rational, and real. 8.88 repeating. So this one does go on forever. It will just keep on adding 8s until our hands fall off. So does that make it irrational? Well, it's definitely real. We know that, but we're wondering whether or not it's rational or irrational. If we remember back to our notes, irrational numbers are decimals that never repeat and do not end. This one does. It would just be 8.88 often to infinity, so which actually makes it a rational number. We can express that as a fraction. And what about 4? Well, it's natural. I was actually about to jump to an integer, but no, it's a natural number. It's a whole number that's greater than 0, or greater than 1, equal to or greater than 1. So natural, whole, integer, rational, and real. Panning on down, we've got -8.5. It's not natural, it's not whole, and it's not an integer either because it has to be expressed as a fraction. I believe this would be -17/2 would simplify down to 8/5. So that is a rational and a real number. Now what about pi? 3.1415, on and on into infinity. One of the classic examples for an irrational number, but don't forget that makes it real as well. Now this was kind of a trick question. 3.14 you'd think is pi, but really it's not. 3.14 is a very common estimation for pi, but 3.14 is just 3.14, which would make it a rational number because it's not repeating. It does end. It ends right after that 0.14, so it's rational and it's real. And moving on down, we've got 3 left. -2.5. Well, it is not natural. It's not whole. It's not an integer because we've got that 0.5 there. It's expressed using a decimal, which makes it a rational, real number. And square root of 71. 71 is not a perfect square. The closest perfect squares that I can think of would be 7 squared, which is 49, and 8 squared, which is 64, which means that falls somewhere in between. That is not going to be something that we can express with a fraction. The closest we can get is just square root of 71. So that is a real number, but it is irrational. 14, this should be old hat for you guys. By this point, that's just going to be a natural number. So all the way over onto the left, natural, and then carry it all the way over to real. It is natural, it is whole, it is an integer, it's everything in between. It's just not irrational. And that is 1.2 homework, types of real numbers. Again, if you have specific questions or want extra insight on these, ask us in class. We'll be more than happy to help you out there. This is just to help you out if there was one that you got stuck on. We'll see you next time.